Can you hear us on the phone okay?
Yes, thank you.
Yes, thank you.
Good, thanks.
Right, we're just about to start. Right, okay. A technology awareness session around blockchain. My name's Les Frost. I'm an architect on the account. I also run this space called the TechHub, which is used to try and get more and more people into technology. So if there's any sessions you'd like, or any more sessions on anything at all in terms of a technology understanding, whether it's a deep understanding, a shallow understanding, anywhere in between, then we're here to help people. So any other subjects, give us a shout. So today we're going to talk about blockchain. And for me, talking about blockchain, it's a bit of a nebulous concept. So what we're going to do first is sit through a sort of 15-minute video on actually what it is. It's going to actually show you some of the key concepts in a blockchain. And then we'll talk about how people use it. So once you've got the basic idea of what a blockchain is, I think the most difficult thing then is to think, well, how could I use this blockchain? Yeah. And so what we're going to talk about is a little bit around things like banking, where today we bank through a central third party. We give money to a bank, they transfer money to another bank, and that's to affect us moving money from one person to another, for example. So blockchain sort of fundamentally could change that idea of having a central authority, because blockchain is what's called distributed, decentralized. So we'll talk about that. So there is the concept of being able to effectively move money around without having a bank. So that means banks are quite interested. And then cryptocurrencies, you've probably heard blockchain in the same sentence as Bitcoin or Ethereum or various other cryptocurrencies. So we'll talk about that. And then a little bit more about this idea of decentralization as a way of knowing whether information is true or not. And then a little bit about what sort of business problems can you solve with blockchain, and then specifically some examples of it being used. That make sense? Yeah. And the last one, which is quite interesting, GDPR and blockchain. That's quite interesting as well, because they are sort of at odds, really. Right, so I'm not, this is just a sort of definition of blockchain, I suppose. So the blockchain is a ledger. So if you can imagine a data structure, a repository that holds details of transactions, imagine that it's immutable, it can't be changed. Right? Every record that goes into it can never be changed. It lives in there forever, unchanged. It's decentralized, there's lots of copies of it. It's encrypted, so the data in it uses mechanisms to make sure only the right people can see it, and only the right people can change it. And so that's a sort of definition. Now that probably won't mean anything to you at this point, but what we're going to do now is go through an actual presentation of the concepts around blockchain. So hopefully this will show you what's involved. This is a sort of relatively technical, but most people should be able to get it, I think. It's got some concepts that most people, I think, understand. Just need the network to work. This worked a minute ago. I'm sure it'll work in a moment.
It was a good one that the BBC did.
Is that? Yeah. There are lots of good examples, I think. Bear with me, caller. Let me just check that my internet connection hasn't timed out. Just 1 minute. Ah, it's not having it, is it? Let me try a different browser. Just hold on 1 moment. That looks better.
This is a blockchain demo. We're going to do this in a very visual way, though. We're going to make it very easy to understand by stepping through the key pieces of what a blockchain is in a visual way. But before we get started, we need to take a look at this thing that we call a SHA-256 hash. Okay, and a hash, this is one of them right here. A hash looks like a bunch of random numbers. And essentially what it is, it's a fingerprint of some digital data. And it just so happens it's a fingerprint of whatever I type in this box. So if I type my name, Anders, into this box, you see that the hash has changed. As a matter of fact, it changed every time I typed a letter, right? So I'm going to go back to this. So it says Anders. Okay, so this is the hash of the name Anders, all lowercase. It starts with 19EA, right? Okay, so if I delete that and I go again to Anders again, you can see it starts with 19EA, the same exact hash. In that sense, it's a digital fingerprint of this data. Whatever data is here, every time you type exactly the same data, you get exactly the same hash. And I can type anything I want. So you can have nothing, like this, E3B0, that's the hash of nothing. Or you can type tons and tons of stuff. As a matter of fact, you could put like the Library of Congress in here, and you would get a hash. And the interesting thing about it is, regardless of if there's a tiny amount of information, no information, or the entire Library of Congress, you're always going to get a hash that is this long, this many characters. So you're not going to be able to pre-guess what this is. You kind of have to put the Library of Congress in here to figure out what the hash is, but you'll always get exactly the same hash regardless of how many times you put exactly the same information in. So what I'm going to do is extend this idea of a hash into something that we're going to call a block. All right, so let's take a look at a block. So this is a block, and it's exactly like the hash. It's just that that data section I've broken out now into 3 sections. One called block. This is just some kind of a number. This is block number 1. Nonce, which is just yet another number. We'll go into what that is in a second. And then just some more data, just very similarly to the way that we had it before. However, the hash of this, which includes all of this information up here, is down here, and it begins with 4 zeros. You see that? It has a relatively unusual hash. Most of them are not really going to start with 4 zeros like that, but this one happens to. And because it does, totally arbitrarily, I'm going to say that this block is signed. Okay? So what would happen if I were to change any one piece of this information? Let's say if I were to type something here. Right? The hash is going to change. And what's the chance of that if I type letters, this hash is going to start with 4 zeros? Pretty low. It's probably not. Right? So let's see what happens when I do that. I'm just going to say hi. Oh, look at that. Right? This hash does not start with 4 zeros. And so the big background here is turned red. So now you know that this block with this information in it is not a valid or a signed block. Okay? And that's where this nonce comes in. This nonce is just a number that you can set to try to find a number that fits so that this hash starts with 4 zeros again. All right, so how do we do that? Well, let's start with 1. Does that start with now? It's 3, 2, so that's not 1. So let's try 2, FF now. 3, 4, 5, 6. You get the idea. Like I could sit here, there's one that starts with 0. I could sit here all day typing these numbers and trying to figure out one that actually is going to hash out to something that starts with 4 zeros. Going to take a long time. So here I have my little mine button. I'm sure you've been wondering what happens if I press that. So what's going to happen when I press this mine button is it's going to run through all the numbers from 1 all the way up to try to find one where the hash starts with 4 zeros. And this process is called mining. Let's do it right now. So now it's checking all of the numbers from 1 all the way up there. Now it's stopped at 59,396, and that one just happens to hash out to something that starts with 4 zeros, and it satisfies my little definition of what a signed block is. Okay, so that's a block. Now, can you tell me what a blockchain is? It's probably just a chain of these blocks. Well, how do you put them together? Let's do that. All right, so here's my blockchain. I have block number 1. It has some kind of a nonce just like before. There's some data area to it, but then it has this previous. Here it's a bunch of zeros. Let's roll forward. So this is block 2 and block 3 and 4. This blockchain has 5 blocks on it, right? The previous here starts with 00 AE8, right? Is this number, AE8. And then this previous, B90 is this one over here, B90. So you can see that each block points backwards to the one before it. You remember that first block over here, there actually is no previous, so it's just a bunch of zeros. It's actually just a fake number. Okay, so just like we did before, what happens if I change some information here? Right? It's going to change the hash of this block, and it's going to invalidate it, right? Well, let's try that. So I'm going to type hi again. Sure enough, that block is invalid. All right, just as we assumed. But what would happen? I'm going to fix that now. We'll go back to something that worked. What would happen if I change something in this block? Right? It's going to change this hash, but this hash gets copied up to this previous. So it's going to change this one too, right? So it should break both blocks. So let me try typing hi in there. Sure enough, all right? So we can go back as far as we want, to some point in the past and break that block, and it'll break all the blocks since then. Everything before is still green, but this one is red. So if I wanted to, change something in this blockchain, I could just go over to block number 5 right here. We could change it. I'll put hi. And then we could remine it, and pick a different nonce. We'll do that right now. And we could essentially alter the chain. So we've done it. So that we should be good now, right? All right, well, what happens if I go back in time to here and I break it here? Now I have to mine this block, which will take a nonce that makes this block hash out to 4 zeros, if we can find one. Sometimes it takes a while because it's got to run through a lot. And there it is. It found one at 138,000. All right, but this one is still broken because although this one starts with 4 zeros, adding the 4 zeros with different stuff up here still makes this block hash out incorrectly. So I also have to mine this block. All right? And that takes some amount of time. That one was a little bit quicker. And then I have to mine this block to fix it. All right, so what we're showing here is that if I go and change this last block, all I have to do is remine this block. If I go way back in time to back here and I make a change, like that, I'm going to have to mine this one, this one, this one, and this one. So the more blocks that go by, the more blocks in the past that we are, the harder and harder and harder it is to make a change. And so that's how a blockchain is going to resist mutation, resist change. Okay, so now, I did. If I do this in this block here, you can see that I've changed it to high and I remined it, blah blah blah. How would I know that my blockchain has been remined? All right, let's take a look at that. I'm going to hit this little distributed thing. So now we have a distributed blockchain. It looks exactly like the last blockchain, okay, up to 5. But this is peer A, the first peer. If we go down here, you can see here's peer B, and it happens to have an exact copy of the blockchain. There's actually also a peer C down here, right? And this could go on forever. There's many, many peers out on the internet. They all have a complete copy of the blockchain. So in this case, if I look at this hash, it's 00E4B, all right? If I go down to this one, I notice it also has E4B. If I go down to this last one, it has E4B, so they must be identical. And I'm going to demonstrate that by going here and typing something. I'll type hi again. And then I will remine this block. I've got some other number, now let's put some other number up here. So I should be able to mine this block. Okay, now all the chains are green, right? They're all green. However, this chain says the last hash is E4B. The bottom one says that too, E4B. And this middle one here says 4CAE. So I know just by glancing at this one little hash that something is wrong in this blockchain, even though all of the hashes start with 4 zeros. I know that this one is different. And it's different because I have 2, it's essentially 2 against 1. We're a little democracy here, right? This guy argues that it's E4B. This guy argues that it's 4CA, and this one is E4B. So E4B wins. So that's how a completely distributed copy, having a copy on many different computers, they can all very quickly see if all of the blocks are identical. And remember, blockchains can have 400,000 or 500,000 blocks very easily. So rather than checking through all of them, all you really have to do is look at the hash of the most recent one, and you can see that if anything in the past, anything way back here was altered, you can tell by looking at this at the last block in this in the chain. It's going to hash out to something that doesn't start with 4 zeros and looks very different from what the hashes on the good chains are. Okay, so that's a blockchain. That's the entire thing. There is no more to it than that. But it's kind of not really useful because we don't have something in this data area that means anything. I keep typing my name or hi, and that's sort of irrelevant information. So what we really want is a token. So let's do a token on our blockchain. All right, now look at this. So I have this token just totally arbitrarily. I'm calling these, I guess, dollars, right? So we have $25 from Darcy to Bingley. $4.27 go from Elizabeth to Jane. You get the idea. It's basically there's all these transactions that are happening. And I've just replaced the data with these transactions. And just like we saw before, so there's multiple blocks here. This one has more transactions. It doesn't matter how many transactions there are. They can be many, or they can be few, or none. If we keep going forward here, just like we saw before, if we go down, we notice we have all these other copies of the same blockchain, right? So now here's where the immutability is important. If I change something back here, you'll notice that this is A7FC, blah blah blah. It's something else. So it's something different than what's down here. So in this way, it's very important that if I were to go back in time and change some value that we would notice. It's very important with money that you don't lose track, and that's the whole point of using a blockchain here. This is the whole point of resisting any kind of modifications, of things that have happened in the past. So that's the reasoning behind using a blockchain to remember tokens. Now, one thing I would mention here is that we're not listing, Darcy has $100 and he's giving 25 of it to Bingley. The only thing we're saying is Darcy gives 25 to Bingley. We're not remembering a bank account balance. We're only remembering money movements. So this begs the question, does Darcy have $25? Well, we have a problem here in this version of the blockchain. We don't actually know if Darcy has $25. So let's look at a Coinbase transaction. So if we look back here at Coinbase, we're going to add a Coinbase transaction to our blocks. And this is very similar to what we've seen before, but we were just adding a Coinbase at the top. And what that's saying is we're going to invent $100 out of thin air and give it to Anders. And there's no transactions in this block because nobody had any money previous to this. In the next block, another $100 comes out of nowhere and goes to Anders. I'm a fan. I love it, right? I'll take $100. Now we have some transactions. You can see that they're all from Anders. They're all from me because I'm the only one who has any money at this point. So I'm sending 10 of my dollars to Sophie. Do I have $10? Yeah, I do. I look back and I see that this Coinbase transaction has given me 100, so I have at least 10 and I can send it on. And you add all these up and they don't go over 100, and it follows sort of the basic rule of a currency. Like, you can't invent it out of thin air. You can't create money out of thin air. Dispersion is controlled. So now if we look at this blockchain that we've created, and we zip forward in time, and we notice that we can see that Jackson is giving Alexa $2. And so does Jackson actually have $2 to give Alexa? Well, we go back to the block before, and we see that Emily, who had gotten $10 from Anders, gave 10 to Jackson. And so Jackson does have the money. So we can just go backwards and find that out. That's actually one of the benefits of having a previous here. It's easy to go backwards. We just look for the block that looks like that has that hash, and here it is right here. Right, so it points to blocks back in time and allows us to trace the provenance of any coin that we want. So that's a basic blockchain, and we're running a currency on top of it. And as you know, blockchains there are many copies. Everybody has a copy of it. So if we mutate, this and make it $6, these go invalid. It does not agree with these blockchains down here. These copies of the same blockchain down here. So this resists tampering, which is what you want for a currency. It works very well for things that are small and transactional, like this. Go ahead and fix that. And they're just a very efficient way to handle agreement on what has happened in the past. It's kind of this immutable history that goes down with time. So that's a basic blockchain and a token on it. We're glossing over some main points, but if you dig into the demo and click through these things and play around with it, you get a better and better idea of how this works. There will be a part 2 where we go into
Did everyone get that? Did everyone get the idea of effectively a set of blocks of data? They are related to each other. They are in a chain. If you go back and change data, it sort of identifies that it's invalid. There's lots of copies which are distributed. So I've got a copy, you've got a copy, everyone's got a copy. So we know that if there's 100 copies, and one copy doesn't agree, then it's probably that person that's fiddled it. And we've got a way of saying, well, actually 99 of us agree, one of us doesn't agree, and therefore that one must be wrong. So is that understandable? I think it is, isn't it? So then you start to think. So if you go back to that, a blockchain is a immutable ledger. Hopefully you got that idea. You can't easily change it. It's decentralized, lots of copies, and it uses quite a lot of techniques around like hashing. This idea that you can take a piece of data, apply effectively a mathematical equation to it, and you get a string, which effectively represents that data. If the data ever changes, the string changes. If the data is always the same, the string is always the same. So that's sort of basic hashing. That's quite in encryption and that sort of thing. That's a sort of fundamental property. So the thing is then, how do you go from that idea of a set of blocks of data to actually any sort of useful application? Yeah. So, if you start looking at banking, that's a good example. And as I said before, if I want to give David some money, especially if he wins it in a different country, then I would have to effectively go to a bank, say I'd like to give David £100, and the bank would take it out of my bank account, transfer it to another bank, add it to his bank account, and effectively we trust that whole process. So those banks are sort of trusted. They're trusted third parties, but we're forced to go through them essentially. If things go wrong, the banks can usually sort it out. They obviously have to put a lot of effort into, are people laundering money? Is David really David? Or is he somebody else? Has he set up a bogus bank account? So they have to do quite a lot in order to hold that position of trust. And quite often that can cost quite a lot of money. So if you take real world examples, this is an example. You can order a US based product as a UK customer. You work it out using today's exchange rate, and you think that's $1,000. That's roughly 750 quid, looking at today's exchange rate. But what you realise when you get your bank account back and your bank statement, you realise that the banks have used exchange rates that favour them. Yeah, and then they add on something for, well, it's an international bank account, so I'm going to charge you some money. So effectively, they make lots of money. It's a massive business, currency exchange. Billions of pounds a day in currency exchange costs, and billions in this whole sort of movement of money. Yeah. So there are lots of people who look at banking, and they look at the whole idea of a central trusted body which charges a lot of money and potentially takes a lot of time to move assets around, and they say, is that really the best way of doing it? Could I come up with a mechanism that replaces a bank? Well, surprise, surprise, a lot of people are looking at blockchain as effectively a way of getting rid of third parties, a man in the middle that you go through in order to move money, especially in some countries when those banks might not be as sort of trusted as in our country. Yeah, so certainly in other countries the banking systems aren't as well trusted and corruption takes place. So again, people are worried about that. So you've probably come across cryptocurrencies as an example. Now you might argue that, so say Bitcoin, you might argue that Bitcoin's a bit of an odd thing, its value goes up and down. Most people are buying Bitcoins to make money, they've probably lost money. But I suppose what they demonstrate is that underneath the sort of ledger application that they use, which is the blockchain, is capable of transferring money. Yeah, whether you agree with the currencies, the underlying blockchain mechanism has proven to be pretty stable, pretty reliable, and there have been very few cases where the movement of money on top of a blockchain has actually ever been hacked. There have only been a couple of examples ever. So there are lots of people interested in a digital ledger like blockchain. They are looking to see how they can exploit that, and I suppose one of the best examples so far is this whole sort of cryptocurrency area. But there are quite a few other examples. When you look at it, when you look at the mechanism, a lot of it is about decentralization. If there's 10 of us stood in a circle and I give money to David, and you've all got records of it, so you can all see that I've moved some money to him, and you've all got a ledger which says I've moved money to him, and all our ledgers agree, then effectively we know that an asset, money in this case, has been moved from one member of the blockchain to another. We haven't really gone through a central point because we've all got copies of the data. So this idea of decentralization, lots of copies of stuff, publicly available or privately available in a big group, is a good way of a sort of signing trust. We can all see the data, we've got lots of copies of it, so if they all agree, then we can trust effectively what's gone on. So that concept of trusting things is quite important. And generally today, we trust financial institutions, but we pay for that trust, essentially. We trust them. What a lot of people believe is that with things like blockchain, you should trust the technology. You should trust that idea. A decentralized ledger, that is very, very difficult to change. Now, you might have seen in that example, you might have heard about Bitcoin mining. You might have heard that in the press, and you saw that guy mining. Mining is this idea of sort of calculating a value that makes this chain work. And that's what, in Bitcoin, that's what people do. They buy very powerful computers and they compete on the internet to generate those numbers. Essentially, that's what they do. And when they get that number, they effectively get paid a bit of a Bitcoin, so they make money out of it. And that's what Bitcoin mining is, if you've ever heard that term. But fundamentally, they are operating on top of the blockchain. And whether you think cryptocurrencies will take off or not, blockchain as a technology is already taking off. So, if you've heard those two words in sentences together, try and separate the two. One's a currency, one's a ledger on top of which the currency runs. So if we look at different sorts of applications of blockchain, so suppose you are a logistics company and you want to track parcels, important parcels. Then today what happens is, as you can imagine, your post office or your parcel provider has a computer system. You go onto it, you say, I want to move something. That gets moved to a courier. The courier puts it in a van and moves it. They've probably got a tracking system. So everyone's got a tracking system, but actually there's lots of them. And data generally moves between these tracking systems, and they can go wrong. And they're quite expensive. Everyone has to have a tracking system. So a lot of what blockchain points at is this idea of, couldn't we just have one distributed ledger with all our parcels in, effectively? Then when they move from one place to another, that distributed ledger gets updated. And then we look at the distributed ledger and we know the current status of stuff. So you can see straight away that if you've got this idea of a secure sort of distributed ledger, how it could be used for things like logistics. It starts to make sense. Because at the end of the day, the ledger can hold any data you like, really. It just needs to be transactional. And we are having lots of copies, so we can all see the up-to-date position. So that's quite a useful concept for driving down cost. Just like they were driving down cost in the banking system, people start to look at driving down cost in other industries.
there's not a problem with you just getting vast quantities of data, because not everybody needs to know what everybody else is doing.
You do, actually, yeah, but today we have vast quantities of data. We have cloud computing and our own computers that are able to process vast amounts of data, and actually processing vast amounts of data today is quite inexpensive.
I mean, DHL must have loads of data, and the post office must have loads of data,
yeah.
But if they both had copies of data, they've doubled.
Yeah, absolutely, yeah. But if you think about it, they all end up, there are so many sort of movements of that data. You're right in that you end up with one ledger that's copied many times. But actually today, that data's probably copied many times, because it moves from one computer system to another behind the scenes, because most of them talk to each other, don't they? So, for example, in my bank account, I talk to HSBC. HSBC have data about me. If David's on Barclays, that's a separate set of data, effectively on a bunch of Barclays systems. And they physically have to make a data transfer, don't they, from one bank to another? Okay, it's backs or something quick, but essentially the data moves. But the point is now that data's cheap and processing's cheap in comparison, and so people are doing this. And the costs of it, I'll show you later, Amazon have a blockchain service that you can go onto, and actually the costs are really quite competitive compared to building your own computer system to store this data, providing APIs to transfer data to other organisations. So there are people using it, so it is becoming cost effective. But I take your point, and you're right, there is a lot of data, but today data's relatively cheap to handle. So, the sort of applications you can use. So, these are just a set of examples. So, if you look at things like voting, voting is quite a good example, isn't it? Wouldn't it be nice if I don't think this browser's. Okay. So this is an example of sort of voting in the modern age, I suppose. This is a platform that you can see it's crowd-funded. They're asking for donations. But essentially, this is one of quite a few, actually, voting systems which are trying to address this idea of, is it a legitimate vote? Have you counted every vote? Is every vote traceable to, not necessarily traceable to an individual, but can I see where my vote has gone? Not necessarily show it to everybody else, but can I prove that my vote went into the yes vote or the no vote? Yeah, so that idea of voting. So there have been a couple of countries now that have used blockchain-based voting in local elections. I don't believe there's one that's done it for a national election yet within a country, but sort of the equivalent of our local elections, there are countries now who've done blockchain-based voting. That's quite interesting. And that trust thing is, again, quite interesting, isn't it? Because, do we trust our voting system? Probably. Do other countries trust theirs? Not necessarily. So that idea of, a ledger with votes in that can be attributed to individuals and verified that they're actually accurate and the votes were counted and cast in the right way, I think is quite an important idea. And you'll see lots of people start to talk about blockchain-based voting. It's quite a good example. So assets. So land is a good, this is quite a good example. So imagine that you had your land registry and you declared the ownership of assets, land assets, in a public register. And then when things were bought and sold in terms of assets, land, you effectively kept that up to date. Much like we have the land registry, today our land registry is built on, I move house, my solicitor fills in a form, the legal, that asset is effectively transferred in the land registry. and that's a sort of central sort of paper-based repository. So this is an example of, and again, yes, Dubai is an interesting country, but this is an example of a country that's decided to put real estate, property records effectively in a register and start using a blockchain register to track when property moves from one owner to another. So that's quite interesting.
And where is it when you say it's distributed to a number of, what were they called? Not tiers, but...
Yeah, well, anybody, yes. You can, so I've got an example in a moment. Yes, so what you could have in this case is all estate agents have, an entry, and solicitors now have an interface to the blockchain, and they would all have a copy of it. Yeah. So you're right, you've got to think about who has a copy, and do they need a copy, and how many copies do you have? But fundamentally, in that sort of solution, the people who take part in those transactions would be the people who have copies of the ledger. So that's quite interesting. They're even talking about using Bitcoin to buy stuff. I suspect they'd probably change their mind on that now, but that's quite interesting. You won't be surprised to know that share trading, another good example of, fundamentally people build huge computer systems nowadays to trade shares. Yeah, it's quite a, as you can imagine, quite a complex area in terms of proving that shares have actually been traded. They've moved from one owner to another. So again, you get people like these guys Trade.io who have a product that people are beginning to invest in terms of trading shares. Yeah, probably massive investment in this one. But again, they're going against massive investment in huge infrastructures that trade shares today. So how well this will get on, I think that's an interesting one. But the fact that people are investing in it and building platforms that do it, I think shows some sort of intent. I suspect this one's probably quite a way off because share dealing is quite complex. But again, it's a sort of good example.
Plus, these things would still somehow have to interact with existing.
They would, wouldn't they? Yeah, absolutely. Yeah, and I think that would start to get complex, I think. But I suppose when you look at investment in these areas, these things are being heavily invested in. So you get the impression that some of them are going to take off. Now, this is an interesting example. This is De Beers diamond miners tracking their diamonds. Now, so far, we've talked about currencies, documents, all of which have some sort of identifier, don't they? But if you think to yourself, in order to put something into a blockchain, you need to be able to identify it. So how would you identify? I have two diamonds in front of me. How would you know that this one came from a De Beers mine and this one didn't? How would you do that? Because fundamentally, you've got to be able to turn a physical thing into some sort of identifier. Because you can't put the physical thing in a blockchain, so you have to have an identifier, don't you? So this is quite a key concept. You need, so far we've talked about, we haven't really talked about physical objects. How do you track physical objects in a blockchain? So effectively what people do is they, in this particular case, and in all these cases, they come up with some way of measuring the diamond in this case. So in this case, they assign a global diamond ID. So effectively, they look at it and they look at its properties, and they give it a fingerprint that says, its luster or its what's shiny? I can't remember what the term is, but yeah, clarity, carat, colour. So they effectively look inside this diamond and come up with a mechanism of measuring it so that it's different to every other diamond. just like fingerprint. They're effectively looking for to be able to assign a number to it and make sure that if they've got the diamond and you scan it with the scanner or whatever, you always get the same number. So that's the sort of thing you've got to do. So when you think about, if you hear people talk about using blockchain to track cattle so that you know where meat production's been done, you have to think to yourself, well, yeah, that sounds a little bit tricky actually, because how would you, fundamentally identify a cow, say? So you've got to think about, when people talk to you about applications of blockchain, is there a way of uniquely identifying something? Because if there isn't, it's probably not a good not a good example for blockchain. I'm sure there are lots of ways to identify cattle, but I'm by no means an expert, so and it's probably a sensitive subject, so. And here's another one on food manufacture. Yeah, so this is starting to look at ingredients, where they were sourced, how they followed through the food chain. Yeah, so again, you can start to see how eventually you may well get, instead of me buying raspberries at Marks and Spencer's that say they came from Morocco, I may well be able to get a full history of where they've come from if that raspberry can be identified, which is questionable. I suppose the pack that it's in could be identifiable, but you've got to get real with some of this stuff. Fundamentally, you've got to have a way of uniquely identifying things to be able to put them in a blockchain. So hopefully that gives you a sort of the sorts of applications that you can start to use with blockchain. Right. So let's now make it a little bit more specific. Let's start talking about tax and blockchain. Yeah, so because that's quite an interesting area for us. So, not in big countries, but in smaller countries, there are already examples of people looking at blockchain. So, this is talking about Thailand. This is talking about VAT refund, things that we do in the UK, and this is talking about putting effectively VAT receipts and declarations on a blockchain. Yeah? So actually having a centralised register, a distributed ledger of VAT information. So that's quite interesting. Difficult to get information about where this is going or how far they've got, but certainly they are announcing it. So I don't know when this was. Yeah, December, end of last year. Yeah, so publicly going out and saying we're going to start using blockchain to track VAT because we think there's a lot of VAT fraud, and we think the blockchain mechanism will help us get to the bottom of what is being moved and is it being moved reliably. So that's quite interesting, I think. Probably worth sort of keeping tabs of that sort of thing. This is quite an interesting one, a bit closer to home, although maybe not for long. So this is the German Fed, effectively, November 2018, talking about money laundering. So the Germans have had a couple of these, haven't they, where effectively businesses or fraudulent businesses are laundering money through schemes that they have. And again, they're talking about, so this is the German Economic Federation effectively talking about using blockchain to try and drive out fraud. Again, quite interesting. When you see figures like that, they believe $5 billion was what sort of cleaned up through the German tax system, effectively. So again, that's quite interesting. The Germans, they're pretty mainstream, yeah, pretty conservative, really. So if they're talking about it, that's quite interesting. And the Chinese. So the Chinese are, I think they've issued August 18. They've started to do invoices, effectively through some sort of blockchain mechanism. Again, they're starting small, and there'll be lots of systems that process invoices. But I suppose when you start getting, I don't know whether you've ever bought anything from China, but that's probably where you got it from. That's one of the biggest industrial regions of China. They are starting to talk about putting invoices in blockchain. So again, quite interesting. End of last year. So all this stuff is beginning to build. Where people are starting now to get into a commercial exploitation of blockchain. So I think to your point, if you start to look at, so Amazon have a blockchain service. I've used this myself. This is quite neat. So I could go on today and create a blockchain on Amazon. So they've got a service that allows me to do that. I would define the data I wanted. I can define the participants that I want to be able to come and look into this ledger. I can give them roles and access into my blockchain. It's sort of built around the same idea. We don't want a centralized repository. We want a repository that's distributed across many parties. They do the manipulation that keeps all these copies up to date behind the scenes. You can just pile data into it, and they replicate the data into these blockchain ledgers. So that's available. So the costing of that's quite interesting. It's the costing of Amazon services is quite interesting in general, but this one particularly is the sort of amount of data and replica based, which is quite an interesting model. So if you have 100 copies of your ledger, then there's a cost, and depending on how much data your ledger contains, there's a cost. The costs are fractions of cents per gigabyte, but so the calculations I think are quite difficult. But when you look at the uptake of this service on Amazon, they're reporting that there's been quite a lot of uptake.
Do all the replications sit in AWS as well?
That's a good question, actually. So quite often with AWS, they start off that way.
Yeah.
AWS often has the idea of having some on-premise and cloud service combined. So I don't know in this particular case. It's a good question.
We're all scared of the big bad financial institutions. Guess what? Amazon can solve the problem.
Correct.
And guess what? Google can do it as well.
Correct. And you're right to point out that Amazon is a big bad financial corporation. No, you're right. Yeah. So, but I suppose my point is that 2 years ago, if I wanted to have a blockchain implementation, it would have been really difficult. Right? I would have had to understand the technology on which blockchain is based. I would have had to buy some infrastructure. I would have had to install lots of open source software, manage it. When cloud providers start moving in, you know that there's a commercial basis because they are only interested in, if this service didn't take off, it would be closed down. That's how brutal cloud providers are. They're in it to make money, and this tells me that it's serious if AWS and Azure, Microsoft are investing in it. So for me, as a sort of technologist, this begins to show me that this sort of technology is going places. So the last sort of subject, this is quite an interesting one. So GDPR, data protection, one of the fundamental tenets of GDPR is the ability to delete data, isn't it? So I should be able to say, you've got my data, I want you to tell me what you've got about me, and actually I want you to delete it. That's quite interesting compared to the blockchain, which says we can never delete data. Yeah. So that's quite an interesting dilemma. So interestingly, so encryption is the idea that I can take some data, I have a private key which allows me to encrypt data, and I could give you a key that allows you to decrypt it and read it. So there have been laws passed now which say if I destroy this key, that data can be considered as deleted. So I don't delete the data, I delete the key, right? So what tends to happen in this case is that instead of deleting data from the blockchain, they use individual keys to encrypt data, and then they prove that the key's been thrown away, as opposed to the data's been thrown away. So the data remains, but it can never be decrypted, if that makes sense. And that, for now, so you get quantum computing, which will blow away all that. Yes, but for now, that is seen as sufficient for GDPR and blockchain to interoperate, which is fairly recent. That sort of legislation is coming through in quite a few countries in order to, well, European countries mainly, to tackle this incompatibility, because fundamentally people thought, oh my God, how can you have a system that never throws away data, but laws that say you've got to be able to throw it away? How does that work?
So they have to encrypt each transaction, and each block in the chain is encrypted separately.
What they actually do is that each person who writes data into the blockchain has a encryption key where they write it.
Right.
Now, so what gets written in is not data that anybody else can read, but they know it hasn't changed because of the blockchain, and then whoever you want to read it, you can effectively give them your what's called a public key, which allows them to read it. And then when you no longer want them to read it, you effectively, you effectively throw away the key. And that's quite difficult to prove. But then you get people who put the keys in blockchain and prove. So it all gets quite complicated. But fundamentally, people are working through this idea of legislation that says you can't change stuff versus stuff that's blockchains that never get changed. So I think that's quite an interesting area. So hopefully, coming out of that, you might know what blockchain is. I think that demo, just keep that in mind. It's a set of data, it's in blocks, they link to each other, you have many copies of them, and if any bit ever changes, you realise that it's changed. Fundamentally, that's all it's about. Just think sort of double entry bookkeeping, but on steroids, that's all it is, yeah? And then think about distributing that to lots of people means you can trust it, because you've got lots of copies of it, and if a couple of copies aren't in line with everybody else, then they're wrong, and you're right. It's a democracy. And then think about, well, I could use that mechanism then to get rid of banks, because they cost a lot of money. I could trust the blockchain to do this sort of thing automatically, and I wouldn't have to pay a bank in order to move my money. And then think about, well, if that works for banks, wouldn't it work for moving goods or moving diamonds or voting or a whole host of other things? And then for me, keep tracks with these things where countries are starting to say, well, I'm actually using this technology, and see where that goes. I mean, I don't know whether HMRC have ever said they're interested in blockchain. I don't really know. Not so close to them anymore. So
no, I don't know. Does anyone come across them?
Are they collecting tax on the money that people make on cryptocurrency?
Right, yeah.
Are they?
So they've issued some guidance recently, haven't they, that said effectively profits on cryptocurrencies are like increasing assets, aren't they? So they should be taxed. I don't know whether they currently are. I didn't see anything on my tax form that says you can put cryptocurrencies in.
I don't know if you can hear me. It's Dave Daly.
We can, Dave, yeah.
Yeah, HMRC have got to be interested in blockchain, because their clients, their customers will be using it.
Yeah.
And they're going to have to defend against it, so they're going to have to understand it.
Yeah, I would agree with that, definitely. Good. So hopefully that's given you an understanding. Hopefully now you understand what blockchain is, and when people ask you, you can say what it is. Welcome to the world of distributed ledgers. It's quite an interesting world. Good. Any questions? Did that make sense?
Yeah, I think so. Yeah, it's quite takes getting your head around it a bit.
It is.
It's simple at basics, but
yeah,
it's an application.
Absolutely. The applications of it, I think, once you start thinking about it, are quite numerous. Yeah. Any questions on the phone?
Not from me, thanks, Liz. That was great.
Good. Right, in which case we'll finish up there. Thank you very much.
Okay, we'll give Les a clap as well, thank you.
Thank you.
Cheers, Les.
Cheers, guys.
Thanks, Les, much appreciated. And as Les said at the beginning, if there's any more thoughts on topics, do say.
Yeah.
Canvas around the team as well.